Hey guys, welcome to my channel. Today we are going to discuss one of the most important concepts in system design, which is scalability. And this is something that becomes super crucial as your application starts growing. Because a system that works perfectly fine for 10,000 users might completely break when it suddenly gets 1 lakh or 10 lakh users. So, scalability is basically about preparing your system for the future, not just making it work today. And in real world applications like Instagram, Twitter, or banking apps, the number of users or requests and data keeps increasing continuously. So, if your system is not designed to handle that growth, performance will degrade, users will face slow response. So, which is definitely not acceptable, right? So, in this video, we will break down what scalability really means, how system handles increasing load, how companies like Twitter or Instagram scale, what are the key performance metrics like latency and drought, and also we'll go deeper into real world challenges like data inconsistency in microservices. And trust me, by the end of this video, you will have a strong understanding of how scalable systems are actually designed in the industry. So let's understand what scalability actually means. In simple terms, scalability means how well a system can handle more work without slowing down. It is not just scalable or not scalable. Instead, it is about what happens when the load increases. For example, what if the number of users doubles? Or what if the data becomes 10 times bigger? Or what if many requests comes at the same time? Scalability is about how smoothly the system handles these changes and how easily we can add more resources. Now, before we even talk about scaling, we need to understand something called load. Because you can't perform or you can't scale a system if you don't know what kind of load it is handling. And load is basically the demand placed on your system, which can be measured using different parameters like requests per second or number of active users or read versus write ratio. And these parameters completely depend on the type of system you are building. For example, in a web application, you might measure requests per second, while in a chat app, you might care about concurrent users. And sometimes the average case is important. But in many real world systems, the real challenge comes from the extreme cases like sudden traffic spikes or viral growth. And that's where systems usually fail. So, understanding load properly helps us design better architectures and also help us answer questions like what happens if load doubles and how should we prepare for that growth. So, load is basically the foundation of scalability. Now, let us understand scalability with a simple real world example using Instagram. On Instagram, there are mainly two actions: user posts reels or photos, and user opens the app to view the feed. The important thing to notice is that the number of reads, that is, people viewing feed, is much higher than the number of writes, that is, people posting content. Millions of users scroll their feed every second, but few users post at the same time. Because of this, the system needs to be very fast at showing this feed. At first, you might think that whenever a user opens the app, Instagram can just fetch posts from all the accounts they follow. But this would be slow and inefficient, especially if someone follows 100 or 1000 of people. So instead, Instagram uses a smart approach. When a user posts something, the content is prepared or pushed in advance to their follower. This helps the app load feed instantly when the user opens it. However, this approach also creates a challenge. If a celebrity with millions of followers posts something and sending that content to everyone at once becomes very heavy and can overload the system, right? To handle this, Instagram uses a hybrid approach. For normal users, posts are pushed to followers, but for very popular accounts, posts are sometimes loaded only when the user opens the app instead of sending them to everyone in a